Welcome to the DIY Honda Garage channel. This presentation addresses DTC P1683, indicating a problem with the throttle valve default position spring performance in the Honda CR-V 2023 and later models. The throttle valve is a crucial component of the vehicle's throttle body, responsible for regulating airflow into the engine based on driver input. When this valve fails to reach its expected position, the Powertrain Control Module, PCM, identifies an anomaly, triggering the DTC P1683. The throttle body itself is located within the intake manifold, connected to the fuel system, and is critical for optimal engine performance. If you ever choose to troubleshoot this error, please be cautious and avoid placing fingers in the throttle body while the ignition is in the on position. This can lead to serious injury due to the potential activation of the throttle valve. The error P1683 is specifically related to the throttle valve's default position spring performance. The throttle valve plays an essential role in managing the amount of air that enters the engine, directly impacting the combustion process. If the throttle valve fails to reach the intended target position, it signifies that either the spring mechanism is malfunctioning or there is an obstruction in the system. The PCM, or Powertrain Control Module, is responsible for monitoring various engine parameters, including the throttle valve's position. Should it detect a discrepancy, it sets the DTC P1683 to alert the driver or technician of a potential issue that needs addressing. Understanding the location of the throttle body, nestled within the intake manifold, can help diagnose issues more effectively, especially as it relates to airflow and engine performance. There are several possible causes for the DTC P1683 error. One common cause is a stuck throttle valve, which can inhibit its normal operation and prevent it from reaching the designated position. Another likely culprit is a dirty throttle body, where carbon buildup can obstruct the valve's movement and mislead the PCM. Additionally, a faulty throttle body spring may prevent the valve from returning to its default position effectively, thus leading to an abnormal reading by the PCM. Inspecting these components thoroughly can uncover the root of the issue. Addressing these potential causes will help restore proper functionality to the throttle system and eliminate the error code. Consider each possible cause during your diagnostic process to increase your chances of successful repair. The symptoms linked to the P1683 error can significantly affect vehicle performance. One of the most noticeable signs is poor engine performance, where the vehicle may exhibit erratic acceleration or struggle to respond to throttle inputs. You could also experience an unresponsive throttle, preventing the vehicle from accelerating normally. Additionally, the check engine light will be illuminated on the dashboard, signaling to the driver that there is an issue that needs attention. These symptoms are the vehicle's way of indicating that there is an underlying problem with the throttle valve and its associated systems. Identifying these symptoms early can help avoid more severe damage to the engine or other components, making it crucial to address them promptly. For the first step in troubleshooting DTC P1683, start by starting the engine and holding the engine speed at 3,000 RPM without any load. Ensure the vehicle is in park or neutral. It's essential to maintain this RPM until the radiator fan engages, as this indicates that the cooling system is functioning correctly. After this, let the engine return to idle speed. During this process, you are monitoring the throttle's behavior and assessing whether it is functioning according to specifications. Each of these actions helps the PCM gather data that can determine if the throttle valve operates correctly. After running through this step, you will be better equipped to identify if the problem lies with the throttle mechanism or elsewhere in the system. The second troubleshooting step involves turning the vehicle off and waiting for approximately 10 seconds. This brief pause allows any remaining electrical charges within the system to dissipate, helping reset any transient errors present in the PCM. After waiting, turn the vehicle back on to reinitialize the throttle system. This procedure is critical in determining whether the previous anomaly was a temporary glitch or requires further investigation. After following this step, the PCM will reevaluate the throttle valve to see if it has resolved the issue or if P1683 persists. Attention to detail during this step can inform subsequent actions to take for successful repairs. In the third step of troubleshooting DTC P1683, you actively engage with the throttle valve. Begin by pushing the throttle valve closed as indicated in the inspection guidelines. Once it is closed, release the valve to allow it to return to its default or resting position. Under normal conditions, the throttle valve should smoothly return to its initial state without sticking or hesitation. This test allows you to assess the mechanical functionality of the throttle valve and identify potential issues. If the throttle valve does not return to the default position as expected, it suggests that there may be a blockage or mechanical fault with the throttle body itself. Documenting the results of this check is essential for informing further actions in your diagnostic process. The final troubleshooting step addresses the throttle body cleaning procedure if the previous inspection indicated normal functionality. Begin by performing a thorough cleaning of the throttle body, which can often eliminate carbon buildup and other obstructions that may interfere with the throttle valve's operation. Once the cleaning is complete, use the confirmation procedure outlined in the earlier steps to retest the system. During this retesting, you should closely monitor whether DTC P1683 is present. If the code does not reappear, we can confirm that the cleaning addressed the fault and the throttle body operation has been restored to normal. However, if P1683 is still indicated after cleaning, further investigation into the throttle body or related components may be necessary to ensure everything is functioning properly. After completing the troubleshooting steps for DTC P1683, it is crucial to conduct a final repair verification. Begin by ensuring that no P1683 error codes are present in the system after your corrective actions. Next, confirm that the throttle valve is operating smoothly and responding correctly to driver inputs. Additionally, monitoring the engine's overall performance during initial test drives helps ascertain that the problem has been fully resolved. It is important to test in various driving scenarios to guarantee the throttle response is consistent and reliable. Documenting these observations, along with the absence of any fault codes, will serve as vital information for any future diagnostic procedures and provide assurance that the repairs were successful. Preventive maintenance plays a vital role in reducing the likelihood of encountering DTC P1683 or similar throttle-related issues in the future. Regularly scheduled throttle body cleaning can greatly minimize carbon buildup that commonly obstructs valve operation. Continuously inspecting the throttle assembly for any physical wear, damage, or obstructions ensures that the components remain in optimal working condition. It's also essential to monitor overall engine performance and address any irregularities as they arise. By establishing and adhering to a preventive maintenance routine, vehicle owners can significantly enhance reliability and longevity. This proactive approach can save both time and costs in the long run by reducing unexpected repairs. In conclusion, addressing DTC P1683 effectively requires a thorough inspection of the throttle valve and related components. The steps outlined in this guide are designed to help technicians pinpoint the issue efficiently. Cleaning the throttle body is often a key solution that can rectify the problem, provided that the valve's mechanical integrity is intact. Monitoring vehicle performance continuously after repairs is equally important to ensure that no further problems develop. Understanding the components involved and their functions in relation to the error code ensures that repairs are both effective and enduring. As a proactive step, implementing preventive maintenance regularly can significantly mitigate future issues and enhance the overall reliability of the vehicle. Please like and subscribe to the channel. See you next time.